Okay, there we go, finally. Okay, so for those of you guys that are here for the first time, this is like, what, our 5th class or something?
Yeah.
So we've worked through, we started this looking at building from the ground up. So we started with our foundations, concrete, all of that stuff. So the last class before Christmas, we went over kind of the history of framing and to give a framework of how we got to where we are today. And then today, we're digging into platform framing, which is it's the way that like 99% of the wood frame buildings are put together today. So we're going to dig into this in depth, a little bit more in depth today. Next week, we're going to look at, I think it's we're either looking at sheathing and insulated sheathings next week or trusses. I can't remember which I got on the schedule. But here's where we're at today. So today I want to look over key concepts, some problems to avoid, how we deal with space conflicts, a bunch of layout options, and then we're going to look at hopefully we'll have time to look at one plan. This is just a little diagram here of the typical platform framing configuration where we get our wall and then we build the floor on top of it and then build the next floor on top where the next wall's on top of that and so on. So, okay, and so I got a couple of videos here to, I guess, give a big framework of why it's really important that we do this stuff right. We got this little picture of this partly collapsed house from snow loads. This one here. Okay, that's an apartment building in London a couple of years ago.
Anybody who is speaking to the building, they need to ring 999. There is a dedicated line for this incident.
I ran outside and then looked up and it was just a blaze. Everything, it was an absolute nightmare. It was like something out of a horror movie.
And then suddenly I saw that big flames coming out in the window, inside to the flat as well. I tried to put it out, but because it was too strong.
I saw people jumping out the window. It was crazy. I saw people jumping out the window.
There's a lot of dead bodies, a lot of kids, and a lot of dead bodies that were all on the floor. They were obviously covered up, but there were a lot of people that did not make it the fall.
We rescued large numbers of people from inside the building very early on across a range of different floors. I've spoken to crews who've been up as far as the 19th and 20th floor. In my 29 years being a firefighter, I have never ever seen anything of this scale.
Okay, so that is like,
Actually saying, are you guys coming? Are you guys coming?
that's the worst apartment building fire of like the last few years. It's the Grenfell Tower in London. And then this one. So I'm showing you guys this because it's important to know that the reason we do some of this stuff is because at some point somebody's life is going to depend on it. So this here is like a neighbor or something taking some video of this house, and so we're not going to watch the whole 10-minute long video, but I'll just click through this so you guys can see the way a fire progresses. Like Brady, with your firefighter experience, like how much of this house do you think is going to survive?
Not much.
Not much.
We had a house
okay?
fire last week.
Yeah.
Home's gone.
Yeah.
And we were there quick.
Yeah, and like this is the city, whatever, like it doesn't really matter. When the house is this far burned before the fire department gets called, like,
It's gone.
so.
You can't go in.
That's fast. That's a minute and 27 seconds in.
That's been going.
There's 2.5 minutes in. So they're fast, right? Like these guys got here insanely fast. They're getting their hoses set up.
The wind's going right toward the house too.
The wind's pushing forward.
Okay, 3 minutes and 10 seconds till it started getting out of the water. That's insanely fast. Okay, still burning like crazy because that one hand line was not enough to hook myself, like, knock it down. Now they got another one, now they're making some progress, ladder truck coming. As soon as the smoke turns to white, you know they got a fire. There we go. They might have to demo most of the house. Yeah, I mean, look at this, it's burned all the way through. Let's go back, okay, watch this up here when they hit this. Look at, like they're blowing entire sheets off the wall. Oh, there. They're hitting this roof. The water's blowing right through the roof. The shingles are blowing off the sheathing's completely burned through it. The shingles are up there. So we're down to bare studs. Roof sheeting's gone. So this is the reason, like, we can build a house that can hold up to fire really well. We just have to put some certain things in place. We can build a house that can handle snow like this. Like, you can see the amount of snow on this roof here. That's not really that much snow. And so, like, we can build a house to handle that load. We can build a house that can be fire resistant. We can certainly build a high-rise apartment that is fire resistant. And so, what I want to do, what I want to be careful to not do with this class is I want to avoid giving you guys like highly specified, highly detailed information that could make you think, if I do it exactly like this, everything's going to work. So building is a very complex environment, and we have, like, at any point in time, a building has to account for a multitude of different factors, and your fire resistance of the structure, you never ever know when it's going to need that quality. And so building is not like, oh, if I do A, B, and C, every time everything's going to work out okay. It's not quite that simple, and it's not that friendly. It's significantly more complex, and so what I want to be able to do is give you guys like a big picture of stuff and give you some really good tools, and then if you're going to work in this trade or any time that you're working with a building, you have to be able to draw from like fundamental concepts, and then you're going to have to figure out in the field, how does that concept apply to this structure in this location with this shape, because there's no possible way that anybody can teach you a class that's going to teach every single application. I'd be a fool to try to do that because it can't be done. And so I have to just teach bigger concepts, and then you have to be able to take from like all these different things and pull it together to make a project work. Okay? Okay. So, fundamental things, concepts: square, plumb, level, and true. So that's what we're looking for when we're building. We start, I have square listed first because it doesn't really matter how plumb or level a place is if it's massively out of square. So we can build a structure, we can build a really good structure that is not square. We've worked on some remodels that are insanely not square. We remodeled the guy's old milk house into a tiny house years ago. It was a 20 by 20 building that was 17 inches out of square.
Wow. That's a lot.
So it's like a diamond shape instead of a square. So it can be done, right? And everything worked fine. We just had to like tweak things a little bit here and there. Like the skylight that got put in was like 8 inches in the 4 feet, was like, I don't know, something like 7.5 inches out of parallel with the one wall. But it was fine, right? Everything worked, we could put it together. It's much easier for all of our systems if the house is square. And so making sure that it is square when you lay your footings and build your walls is very helpful, but we can get around that. Building it out of plumb, if it's designed that way, like lighthouses have walls that are not plumb, they're tapered in, and that works. But if you have a building that's designed to have plumb walls and they're not, then that's a problem. Level is very important for kitchen floors. Being out of level is a problem, unless you like to have your eggs fried just on one side of the pan. So there's a lot of places where we build things that are not level, like we'll taper a garage floor to a drain and all of that. Sometimes we'll build like the whole garage floor, like sloped towards the overhead door if they don't want a floor drain. So there are particular cases where you would build something not level. But in general, we want it to be as level as possible. Does anybody know what this thing here is in the middle of the screen in the picture?
Level? Old level square?
It's a plumb bob level. So you got a square. It has marked in the middle like the 0 degree line, and then the plumb bob hangs. You set the thing on your piece, and wherever the plumb bob is, it tells you how many degrees out of level it is.
Wow.
So pretty cool.
Yeah.
So this is from, it looks like the Museo Galileo, so it must be like a museum of Galileo's tools. They say this is kind of like the kind of level that they used to build the pyramids.
Wow.
So, and then there's also plumb bob, like level things for setting walls plumb. Like they have this flat base piece, and it has a little arm out, and the plumb bob string hangs down, and the plumb bob, and then it has a little like tape measure thing built onto it. And anyway, so interesting tools. Does anybody know what true is?
False.
Okay. So generally true from my experience in the building trades, is referring to a, like a door or a window opening. Let's see. When we have a door, you can close the door and it closes against the stop all the way around here. If this opening is not true, meaning it's not equally matched to either side, and you put the door in flush with your wall surface, you'll close, and you'll see this a lot of times. You pull the door closed, and like you'll hit the jamb at the top, and you'll have a big gap at the bottom, or vice versa. And so you can check that if you're going to install something. Even before you put the door or the window in, you can take your string line, you can run a string diagonally, and then diagonally that way, and if the strings are just touching in the middle, then the opening is exactly true, like the sides are exactly parallel to each other. If there's a gap between the strings, or they're like deflecting one way or another, then you can see that the sides are not matched to each other. So, okay. So this one is important here. This first one, it is going to transfer when we get to trusses. So when we build a house, we have a whole bunch of different surfaces or planes to the building. So when I have, you know, let's say we've got our wall here, I have to brace this wall to prevent racking. So like if anything pushes on the top of it, the bottom is going to be bolted down to our foundation. And so if I have a load that pushes on it this way, I have to be able to resist that force so that the wall stays straight and the building doesn't just like tip over and fall down. And so if I have this surface braced, then it's rigid this direction, but that doesn't help with anything going the other way. So then I have this other wall going back this way, and if the wind blows on this surface and pushes it back this way, this wall isn't resisting that, this one is. And so we brace each surface of the house because they all interlock and work together to resist loads, horizontal loads applied to the house from any direction. Then, I guess I should have started this down lower. So here's my wall. And, well, that wasn't quite parallel, but, so we get our walls, all four of our walls braced, so that whatever direction the wind blows, this thing acts like a continuous box and it resists the loads in every direction. Then we go and we frame our floor across here. Before we put sheathing on this floor, is that going to do anything to resist any twisting or racking of the floor system? No. Okay. In the old days, when we used 1-inch boards, you'll see this in a lot of houses, they would run the sheathing diagonally. Why would they do that?
Diagonal bracing.
Yeah, exactly. If we run 1x6s or 1x8s parallel with the walls of the house, it just makes a right angle. All you get when you run like a 1-inch board across the wall, like let's say let's say here's our wall. With all our studs, if I just run my 1-inch boards like siding, the only resistance I get to racking is where these 2 nails are and this diagonal line from where that other nail is to there. It's like this triangle that literally like is like this. Like that's actual size of my bracing. Yeah, we get, 500 of those, but compared to the leverage of that tall wall and the wind blowing on it, it's not that much bracing. Where if I run my sheathing diagonally, like that, you get from here all the way to here. So your actual size of your brace is, this is 8 feet, this is probably 10 feet, and then this here is going to be like 13, 14 feet. So that's a pretty strong brace. So the same thing with the floor. The reason you'll see almost every single old house will have diagonal sheathing on the floor, because the most important brace system in an older home is the floor diaphragm. Okay? Diagonally sheathing the floor in the old days would lock that floor like this solid piece, and so the only way it could move was for the whole house to either twist or slide or whatever. And so it makes it extremely stiff. And so for us now with platform framing and 4x8 sheets of material, we can come, we'll run our floor joists on here, and then we'll run, a row of sheathing. We'll have seams in here, but we get this 4-foot by 8-foot triangle, and then we run our next row, and then all these edges lock together, and so it makes it like the entire floor is one continuous sheet, and it doesn't allow any flexing anywhere in this floor. And so when you guys get the opportunity to work on like framing a new house, it's absolutely incredible. Like, you can have your walls all braced, you can walk on them, you can be up there and they'll be really stiff, but they'll still like wobble in the middle, and you can still, like, if you bang on something or drop heavy lumber, like, you'll feel the thing shake. You frame your second floor, you cap those walls and you put sheathing on there, and it just locks that building together like so tight and so strong that it stops wobbling and shaking and moving. So we want to look at every single plane in the house and brace every one, because then as we build this structure and we get everything tied together, it makes it incredibly rigid. And a very rigid house is what causes people to feel really safe and comfortable. Like, they get up in the morning and they walk through the house and it's not shaking when they walk across the floor, or the floors don't bounce. And when the wind blows and you're in bed in the middle of the night, you don't feel the house like wobbling and shaking in the wind. So, because like wind puts a massive load on the house, and it is very common for wind to actually like shake a house, and it can be quite scary if you don't understand how they're built to resist that. So, any questions on that? Okay? All right, so part of that understanding how these different building planes or building diaphragms tie together and how they brace one another, we need to make sure that at the connection points between these different systems that they're really, really locked together. Okay? So when we're doing that, the most widely accepted method is a double top plate. So I guess we should go over some terms. Okay, so I'm going to make a quick sketch here of our wall. Okay. Okay, so this is a rough sketch of all the framing members that we would see in a wall system. Like this is like a cross section of the wall. So this here, this is our foundation, okay? Concrete, block, wood, whatever the foundation is built of. If it's a concrete foundation, the first thing we have is a sill plate. Okay? This needs to be treated if it's in contact with concrete. The other industry term for it is the mud sill. Then we have our floor framing built on top of the sill plate. So this, like the rectangle with the X through the middle of it, is the way that the industry draws any. That's to indicate I'm looking at the end of the framing member, okay? So that's how we have our floor joists, because they're running like this into our rim joists, okay? On top of that, we have our floor sheathing. On top of our floor sheathing is the bottom plate for our wall, okay? On top of the bottom plate, we have all of the studs. And within the studs, if we put a window opening in here, we would get studs supporting our header. Then we would have a sill to the window, and if we had any other studs underneath. So then we get these here. I like to call them a shoulder stud because it is a very logical term to me. The other name for them is a cripple. These under the sill our jack studs. This, if it's running full length next to an opening, is a king stud. Okay? Then we have our top plates, and in this case, you know, in this drawing, we've got double top plate. When we're looking at, let's see, I guess we'll put it down here. When we're looking at tying corners of walls together, so there's where our corner comes together. Underneath we have a stud here, and a stud there. And we need to make this corner really strong. On the bottom we have it all fastened to this sheathing, so that ties the bottom together, but how are we going to tie this top together?
Use the top board to fasten each other together.
Yep. So the first option is we've got this double top plate. So then our first one ties together like this. Then the second one, the double top one, we end the one going this way right across here. So it runs that way. And then this one runs out there. And so they overlap at the corners, nail it all together, and it's super strong. So another option that we have, we can build with a single top plate. If we build with a single top plate, we would do this corner and then we would take, I'll grab on the brake hole, I'll grab a strap. We would run a metal strap, different color. We'd run a metal strap down there, and then we would nail it into the top plate.
Do we do that on this place at all, or no? I don't think.
I think these all have double top plates here. So we can build, we don't have to have the double top plate. We can build with a single top plate. But when we do the single, we have to tie it together. And so that's why we'd have to have that metal strap along the outside. Okay, what else do we got here? Okay, so the other, we kind of already went over this last week or last class, but for those of you that were not here, when we build a structure, we have to transfer all loads from the structure onto the foundation. And so a small window opening is not a big deal. But if we have a large beam, let's say we need to put a large beam, carry something on the second floor, and it's sitting on our wall there, and this beam is putting a load, you know, let's say it's putting a load on our wall of 18,000 pounds. We have to be able to account for that load and make sure that it's transferred all the way to our foundation, and we have to make sure our foundation can handle it. So if this, we can look up in the code, but we would have some type of framing underneath that beam that runs down to our sill plate. Then we would come down in this space and we would put some blocking in here of some sort to fill up the space underneath that beam to transfer that load to our sill plate, and the sill plate is sitting on our concrete, and so then we've effectively transferred that load all the way to the foundation. Okay? If we don't do that, 2 years after we build this house, we're going to come in here and this thing's going to be sagged in between those studs. These studs will probably deflect, you'll have cracks in your drywall, it'll be a complete mess. So it's very, very important that we transfer loads to the foundation. Okay, so here's a drawing. Let's see. We can zoom in on that a little bit. Not very much. Okay, so if we're looking at this structure, this is the actual house. This one had a basement under this area. This area is, so from this here out goes on piers. Where would we need, I might go up here. Okay, so we got an outline of this house. Something like that. We've got a stairway here. Oops. Okay. So, and then we'll go, because our basement is underneath there. So, if you get this drawing, how would you want to frame this thing? Okay?
What style of frame?
How would you want to run your floor joists? How are we going to transfer all of our loads? And what stuff do you have to take into account?
All the way to the kitchen appliances, the
Okay.
sinks, the one bathtub, the toilets. Yeah.
Okay, so all of that stuff, like we're gonna say our dead load for that purpose is 10 pounds. Okay? Because it's pretty normal stuff, and probably not tile floors, carpet floors, whatever. So we're gonna say we got a 10-pound dead load. What do we have to do for live load?
40 pounds.
40 pounds, thank you. Okay? Okay, code requires 40 pounds, whether we need it or not. And it's a pretty good number. So, okay? So, do you think we want to try and clear span this so that the basement can be wide open?
Probably not.
Okay, probably not worth it, right? Because it'll add a lot to the cost. We'll probably have to go to like a 24-inch floor truss or something like that. Okay, so what are we going to have to do then if we're not going to clear span that basement?
And we need to put support beams through down the
Okay.
middle.
Down the middle, perfect, okay? So real nice, simple, we'll run a beam, either a beam or a wall, right? Either one will work for me, okay? So then, now all of a sudden, all I have to do is span 12 feet with my floor joist, right? That's pretty easy. What do I do with this stairway opening?
Don't you need to reinforce it
Yeah.
and put like, I don't know, bigger supports on the side of it?
Okay, so my floor joist orientation is like this, right?
Yeah.
So what do I do to carry the load
Oh, I
Put
see.
a wall
on the ends of
underneath
those there?
Put a wall underneath it.
Yeah, but here I got a stairway coming down, so how am I gonna do a wall there? Tough to walk down the stairs.
Put 2 beams on
Right
each
into
side.
the wall. But what?
Put 2 beams on each side and then put one across the top.
A post, you mean?
Yeah, 2 posts on 2 sides.
Okay.
And beam across.
Okay, gotta get our terms right. Okay, all right, so Justin says we can put a post here and a post here, and we can run a beam across. That makes sense? Okay, all right. That's a great, simple solution. I'll show you guys another possible option. We could run the numbers and see how much load this is going to be and how much load will be on that beam. And then we could just put in whatever we need here. Maybe we need 2, 3 plies of this floor joist. and we could throw a hanger and just hang the beam off to either side. That's an option. So part of it depends, how do they want to use the space down here? Like, do we want to have this a wide open game room and have an open stairway, you know? And so the thing I want you guys to start to see is that there are a lot of options to achieve how we're going to frame this thing. And when we go in and build a house, sometimes a lot of the stuff will be done by a designer. You know, they'll talk with the homeowner and like, how do you want to use the house and how do you want it to look and all that. And but you are going to run into times when that work isn't going to be done, and you're going to have to find out from the homeowner, well, what do you want? You know, if they don't care about how this looks down here, you could build a wall in between the, you know, this line shouldn't be here. So, because this is a landing, the entry door is there. So maybe we can build a wall here and have load bearing point there, load bearing point there, and we just have to have a header to carry these 2 floor joists. We could probably do that with 2 2x6s. So, which that's really easy, right? We could put a header across in a wall below the floor. We don't even have to build a flush header into the floor system or a beam into the floor. We could just build it in the wall and set our floor on top. That's
Could you
even
just
easier.
turn the joist sideways and put them crossways, or do they all have to run the same way? Like in there and being able to...
So in between here, could you run the joist like this?
Yeah.
You could. So that's another option. You have to get your layout really exact, because if you're going to run, you know, or you could run all your sheathing on this floor, and then when you get to this, you could end it like in the middle of this beam and then run this stuff this way. I try to avoid that just because it adds to your time when you're building. And like somewhere, I don't know, I'm debating if I'm going to do it this year or next year, but we're going to go into a class on economics, because the economics of building plays a big part in our decision-making stuff. So
You're going to do this class?
yeah.
Oh, nice.
Yeah. So that's what I want to give you guys, a lot of different tools on how to evaluate, and I want you to see that we have options. Like, we have so many tools in our toolkit on how to solve an issue. And the thing that I see in the trade so many times, guys, is there's guys that have 20, 30 years of building experience, and they'll get out and they'll go to something and they'll be like, they'll be so trapped in this little box that they're like, oh, well, I have to have this done this way. No, you don't. You have, like, and they'll do something dumb because they didn't understand the big concept of what they were doing well enough to know that they had 4 options to solve that issue instead of 1. And so they think they have one option that locks them in, and they do stupid stuff because they don't realize that there were a lot more ways that they could have solved that issue. Okay? And so that's why, looking at the stair, we just came up with 1, 2, 3 ways that we could support the floor around the stair opening, and you guys have way less than 30 years of experience in the trades. But we just came up with 3 ways. If we kept working on this, we could probably come up with 5 more. Okay? And so that's the important thing for you to remember. You have options. Oh, we lost our screen here. Okay, and then you'll notice, the other thing you'll notice here, this was, it says recessed beam here. The reason that it has that is because we've got this wide open room, no wall across there, right?
Right.
So somewhere we have to carry this load. So this recessed beam noted is for the roof load. But when we're framing this floor, we have to pay attention because when we see this span, we know we're going to have a load-bearing point here and a load-bearing point there. And that's carrying the load area for that beam. If we have, so the one load point is right here, the other is there. So that means we're going to have an area that's loading that because the roof trusses are going like this. So there'd have to be another beam there. But for this one, we've got half the span from the middle to that way, half the span this way. So our load on this beam, and thus on our two load points, is this area. Okay? What do we have? How do we know how much load that is?
Insulating the light.
Okay? And what do we have to do? What's our roof snow load?
3 or 15. Full 20. Okay.
40, thank you. 40 pounds a square foot. And our roof dead load, what do you think?
15. Probably.
Okay, 10 to 15, somewhere in there. You could say 20. Let's, for fun of it, say 20 pounds. Okay? So, this house is 24 feet wide. We've got half of that span, so we've got 12 feet, right?
Yeah.
12 feet this way we have to carry, and we're 16 foot 8, so let's say 17 feet this way. Okay? How many square feet is that?
204?
Okay. 204 times 60.
$12,240.
Okay. Okay. So, how much load's on this point and on that point?
6,120.
Okay. Pretty easy to carry, right? That's a relatively light load for a house, but we have to transfer that from the roof down to this first floor. We need to make sure that we've got solid blocking between our floor sheathing and this beam or this wall, and that we've got a post or something under that point going down to the floor. And so when you're framing your basement, let's say this thing's got a full-length wall in there, I need to make sure that I've got something right under that post point that's going to carry a 6,000 pound load. And I may need to make sure that I have a footing under that point in the concrete floor. And so you've got to be able to look at this plan and be like, okay, I can see that right here I need to have a footing in my basement because I'm going to carry a load on there. You should have a building designer that's making that note, but you're the last one to catch any mistakes or anything that's missed. And so you want to look at, and then you flip to your foundation plan and like, oh, there's no footing in here. Why? That's when you call the dryer, the building design guy, and be like, hey, why don't we need a footing under that point load in the basement? It's only 6,000 pounds, and that floor has got more capacity than that. You could be like, okay. Or you can say, so 6,000 pounds, if my soil can carry 2,000 pounds per square foot, how many square feet do I have to carry that?
3.
I've got to have 3. So if I have a 4x4 post under there probably should have a footing. Otherwise that floor risks breaking under that point load. Okay? So those are the things that we want to be able to start to see when we look at this, when we look at like this drawing here, you know, oh, I got a recessed beam, that's going to be loading there. You know, we've got this floor opening, how are we going to account for that? Is there anything we could do differently? If this house wasn't built, maybe you're like, yeah, let's do something different with that stairway. So any other, let's see. Okay, that's probably enough for right now on that. Go back to here. Okay. All right, so that was talking on transferring all the loads to the foundation. Okay, so the next part, it's your responsibility to figure out how you want to build this structure in a way that works for you. One, with the manpower that you have. Two, with the equipment that you have or other resources that you have. Like, you have to be able to account for that. And so, and you have to figure out, like, if we have, let's just say, for instance, that you pull this plan out and they're showing like a huge footing here, and then they want this nice big open basement for their kids to play in, and so they have a steel beam that's running to here and then all the way to this end, and it's like a 12 by 104 steel beam. So you're like, what the heck is a W12 by 24 or 12 by 104 beam? So you put that into your search engine and it pops up and it says it's a 12-inch beam that weighs 104 pounds a lineal foot. And you're like, oh, this is 38 feet long. 38 times 104 is what?
38 times 104?
Yeah.
3,952.
Okay, so do you have the equipment to set a 4,000 pound beam?
Yes.
Yes.
Manpower.
Okay, so if you do, no problem. Okay, great. If you don't, you're going to have to come up with a different plan.
Lots of me.
Or you're going to have to hire somebody to come in with a crane to set it. Or if you do have the equipment, you have to figure out, like, can this piece that I have do it, or am I going to have to get somebody else to come in and set that beam for me? So,
That's a heavy beam.
Okay. And so that's, let's see, go back to slideshow here. Okay, so that's part of it. You have to figure out, you have to look at it and be like, do I have what it takes to build this the way it's drawn? And if not, can we tweak the way the drawing is set up? You know, maybe if they're willing to put another post in here, this could get re-engineered and probably cut the weight in half. Can you set a 1,000 pound beam? Yeah, you could probably figure a way out to do that even without equipment. Okay? So, okay, then the other part is we have to look at this, and then we look at the notes on the plan, and it's getting a forced air heating system. So, where is the HVAC guy gonna run his ductwork? Through your floor. So, we have to figure that out. If you can't figure it out, you talk to the HVAC guy, and you're like, yeah, Matt, how do you wanna do ductwork in this thing? And he'll be like, well, can we run in the basement? No, the customer wants the whole basement wide open because they're gonna put a bowling alley down there and they don't want anything obstructing the ceiling. Okay, well then we're gonna have to go in the attic. Is there enough room in the truss for that?
No.
Do you have plus room in the walls where we can run down, ductwork down to heat the main floor and all the way down to the basement? And like, so these are the questions you have to start figuring out. And like, okay, then our floor plan's gone. Maybe we have to plan in some spots to put a chase for them to run return air ducts and supply air ducts. So that's your job as the contractor to make sure that all of the other trades can get their stuff into this building. And you want to figure that out before you start building in case you have to change something. So, and maybe it means that you're like, we need to look at going to radiant heat on this thing. So for just a note for you guys, a general comparison to move an equivalent amount of BTUs, I can do it through an 8-inch round duct with forced air, or I can do it with a 1/2-inch diameter pipe and hot water. So if I have a like extremely difficult, like you're laying awake at night stressed out because it's going to be so hard to get a forced air system in here, then maybe you need to look at a radiant heat system because you can move the same amount of BTUs through a 1/2-inch pipe as an 8-inch duct. So it solves a ton of space conflict issues to go to radiant heat. It's generally a more expensive system, but maybe that solving the space conflict issue or the other challenges saves enough money that it's a wash. And then you just have to convince the homeowner.
Oh boy.
So, because some people are like, oh yeah, I was in the house and I love the radiant heat, and others are like, oh, I hate it. And so then you have to understand enough about the heating systems to be able to talk through that stuff and find out like, why did you hate it? Was it a system that was done right? You know, figure out that. And so that's where you need to be able to pull from a lot of different sources of knowledge. And when you can do that, you can solve issues and you can save people a lot of money and you can provide a really high amount of value for them. Okay.
Floor systems, I think, are usually about 6 inches on center, right?
Okay, last note here. Just because it is on the drawing does not mean it is right. Okay? Engineers can make mistakes. Architects can make mistakes. General contractors make mistakes. Okay? So, builders build things all the time. And they have the opportunity to see designs from a whole bunch of different people, from different architects, from different homeowners, from different engineers. And that experience gives them an interesting perspective because they see the ways that a whole range of people will deal with and address different challenges that structures present. And so, in a lot of ways, it gives you a really good outside perspective to the design stuff so that when you get a plan and you can be like, this is dumb. Why are they doing this? Like, this is a $20,000 way to address this issue. when we could do it for 5 this other way. And so that's when you ideally would be able to talk to the homeowner and be like, what's your goals? You know, do you like not care about the cost? Are you really committed to this type of solution? And because there's ways we could do it more cost effectively that would work just exactly as well, you know. So those are the things that just because it's on the drawing doesn't mean it's absolutely right, okay? Okay, we're gonna let's take about a 5-minute break, and you guys can use the bathroom. There's fresh coffee downstairs, and we'll come back in 5 minutes and we'll jump into some other issues. All right, so
Oh my God.
when you start on a project, you need to find out like how rigid the plans are. These were pictures just to show you that like plans aren't necessarily right.
Oh my gosh.
Yeah, I mean,
So
how high is that urinal?
Kind of for Neil.
So somebody was like, well, that's what the plan shows. Like, is that the kind of person that you want to be? I hope not, you know? And so, but that's why you have to be aware. The military calls it, the one Navy SEAL guy read his book stuff, and he says, the most important part of any mission planning is understanding the commander's intent. Because all plans change. And so you have to understand when you go to build something, what is the customer's intent? This here, big picture, like we don't really even have to know. We just, the intent is implied. You want to pee in that thing, right? It's really hard to do it when it's up at a high level.
But there's grab handles so you can like.
We'll take a break and you can demonstrate it.
I didn't say it worked well.
So in this here, the funny thing is, I was looking at this and I was like, can I come up with any reason on why there would be a legitimate purpose for putting a toilet at the top of the 3 steps?
You feel like a king, you just go up there.
I was gonna say, it is your throne.
So, years ago, when I was younger, a bunch of guys went up and worked on some old plantation house in Georgia or whatever, not Georgia, Arkansas. And that's what they had in the house. Like, you went up like 5 steps up onto this toilet that like overlooked the whole bathroom. It was like, that's weird. So, and I went into a place, a business in Ashland. Yeah, a business in Ashland. And they had that kind of thing because the sewer outlet from the basement was that high. They had to put the toilet up that high to be able to have it gravity out the sewer drain. So anyway, so that's where like you have to understand what's the intent, and you have to be able to look at the plan and be like, some plans that you get will barely have enough information to build the project. Some of them won't have enough information to build it. Like, we have gotten plans to build a house that all it had was like outside dimensions, a outside elevation, and a floor plan with where the walls were going to go. And that was it. There was no structural information, nothing. We had to figure all the rest of it out. The other end of the spectrum is a construction for like a government entity. So their plans are like completely specified. They'll have a 1,000-page spec book, 85 plan sheets, and every detail is like it has to be exactly as the plans are, and they still can have problems. So, and so even on that stuff, like government contracting, those plans change all the time because they're still drawn by people, and people can make mistakes. So, okay, and so when you run into a problem on a project, you need to like dig into your plans as early in the project as possible, get very familiar with them so that you know what's going on. You have to be able to get familiar enough with the plans that you can see the building in your mind that doesn't exist yet, because you have to make it take shape and become a reality. And so you need to spend enough time with the plans so that you can see how you're going to build it and develop that process, like think through that process so that when you show up on site to start work, you're not like, oh, let's see, we're gonna do this maybe, or maybe we'll do that, and like you can waste an insane amount of time on a site without getting anything done if you haven't become familiar with the plans before you get there. So, and if you get familiar with the plans, then you can see any issues with it, and you can sort that out before materials are ordered wrong, or before you build something, and then the homeowners walk in and they're like, oh my gosh, I didn't think it was going to be like that. And so hopefully you can catch that kind of stuff if you're familiar enough with the plans. So, okay, so I wrote down some issues on here. Eric and I were talking about some projects last night, and so I added this slide in last night before I went home. So the first one, overdriving nails. Every once in a while, you have to tear something apart. Like something changes, new information comes up, you gotta take things apart. It is extremely simple to adjust the driving depth on a nail gun so that your gun isn't shooting nails halfway through your sheathing. If you shoot the gun and you're like, whoa, that nail head is an 1/8 inch or a 1/4 inch below the surface, that is too deep. And you need to stop right then and adjust the gun so that the nails are getting driven flush with the surface of the wood, not halfway through and not sticking out an 1/8 inch. They need to be flush. Part of it too is, let's see, hang on 1 minute, I'm gonna run and grab a nail gun.
I always like to have it like just a little bit inside, just because otherwise, sometimes your nail.
Did we bring that one back last night? Just take a hammer in.
No.
That means you have to. I put it away this morning.
Yeah, you have it in just a little bit.
I didn't see it in the truck.
If you like, if you hit a,
And you know how
if you not, then it rolls.
I was gonna say, if you're flush every time on good road, what happens when you hit a hard hammer?
Yeah, then it just sticks
Then you gotta
out.
follow behind to someone with a hammer.
A lot of times you gotta do that. It's hard headed.
Okay.
Walking nailer.
Best nailer around.
Okay, so you see on this thing, it's got this really fancy adjustable tip. that is like very, very easy to adjust, okay? We went from all the way in to all the way out in 10 seconds, okay? There is no reason to, bang, shoot a nail in and be like, oh, that's not where I wanted it. There's no reason why you can't go, let's try that, bang. Okay, a little bit more, bang, there we go. And then it can drive like 90% of your nails exactly where you want. You'll still hit, every once in a while, wood will have different density, and so you'll have a nail not drive all the way. And then you just pull your hammer out and whack it in, okay? But if you're over driving, if you're driving halfway through the sheathing, one, all of a sudden, we don't get our, where's that whole bracing? We don't get our bracing that we need, because instead of this nail holding on a 1/2 inch of sheathing, it's holding on a 1/4 inch, and the nail heads can rip out of that really easy. And so all of a sudden, a dumb little thing like adjusting your nail gun that takes 10 seconds means that when this house 25 years down the road gets hit by a 90-mile-an-hour gust of wind, it's going to fall down. Okay? Or 3 weeks after you did the sheathing, you got to pull something off, and you go there with your cat's paw, and you're like, doggone it, who was the idiot that overdrove these nails, because now you can't grab any of the heads with your cat's paw. Okay? So, little details, like super easy things, can make a huge mess later. The other thing is, if you notice with the tip of this adjustable tip changes how far this part of the gun is from your surface. If you hold the gun like this, it just changed. If you hold it like this, it changed. Okay? And so if you're going to get consistent nail depth when you're nailing sheathing, hold the gun the same every time you nail, instead of going like bang, 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 bang. You know, you'll have nails all over the place. You need to be consistent with your nailing. Okay? Okay. All right, so the other thing, one of the other things that drive me crazy. We talked earlier about, as the general contractor, it's your responsibility to make sure that the other trades can do their work in the structure that you build, right? So you have to be able to make sure that the plumber can do his work, that the HVAC guy can do his work, and the electrician can do his stuff. So those are your 3 major subcontractor tradespeople, and it is not uncommon for me to go into a house and you run into something like this. Okay, so we got a 7-foot wide window, okay, in this wall. Because it's over 6 feet, the building code says this opening has to have not 1, but 2 shoulder studs, because it has to have 3 inches of bearing for this header. Okay? So here's our header for the window opening. It has to have 3 inches of bearing, because it's 84 inches. Okay? Then, the engineer says it needs 2 king studs. Okay? So now, down here we've got 4 pieces of framing. Does anybody know how thick that's going to be?
6 inches.
6 inches, okay? Then, our wonderful, ambitious framer says, ooh, I gotta support the end of this sill. So we're gonna slap another one in here, okay? So now we're 7.5 inches. And then, our layout comes right here, so we're gonna put another one there.
Wow.
So, now our electrician shows up, and he has to put an outlet right here. Okay? And the really fun part is, there's another window over here, okay? And this one's a 5-footer, but they're like, ah, what the heck, we're gonna run 2 shoulder stubs there anyway. And then we got this, and darn it, our layout came right there. So now we got 14 inches of solid wood, and the electrician's like, I guess I'll drill through here, run through all these floor joists, and come up over there. But that adds a ton of work. Did you need to have 10 pieces of framing slammed together there to support that structurally? No. Okay? The other one is like, if the engineer says we need 2 king studs here, well then we obviously need 2 king studs there, and it just, so that's somebody that got stuck in the I'm doing framing box, and he didn't think about anybody else on that project. And he didn't think about the customer because he just put $100 of material there right at the window when 50 would have been fine. Okay, and so that's why I'm spending the time on structural stuff and framing and load things for you guys, because I want you to be able to understand the concepts of how a structure works, so that when you get into framing something, that you know, okay, this is what I need to do, but I don't necessarily need to do 3 times that to make it work. So, like, we could look at this type of thing and be like, is it an engineered 20-foot tall wall? Well, then we don't have any choice. We have to do what the engineer said, because that's the only way that we know it's going to be able to handle the wind load hitting that wall. But if this is an 8-foot tall wall, then let's just put in the framing that we need, which would be 1 king stud, 2 shoulders, and we don't have to have a stud at the end of a sill plate. Okay? When you're framing for a window, okay, here's your window opening. If the window opening is 5 feet or is less than 6 feet, we only need a single shoulder stud. Okay? We only need a single king stud. Unless it's an engineered wall and the engineer says something different. Okay? Header, sill. To get to our sill, we don't need a jack stud at each side to carry that sill, because there's virtually no weight on that sill. So all you have to do is run your other pieces on your layout so that the siding guy and the drywall guy and the trim guy have something to nail things into, okay? You do not have to have a framing member at either end of that sill, okay? This, one, it saves you some lumber, it saves you time when you're framing, and it saves your electrician a ton of work. Your electrician will come in here and be like, oh, this is awesome, because he can blast a drill bit through 2 stubs in like 5 seconds, instead of having to drill through the floor and then crawl down the crawl space, 50 feet into the crawl space to drill through 3 joists and then up, and then he's got to go up there and he's got to run his wire through that. Like, by putting a ton of framing in here, we multiplied his work to get 1 wire in there by like 10-fold.
Why would he have to go into the crawl space?
Because he's not drilling through the wood.
Yeah, if you have all this wood and you can't get a drill bit to go through it,
Just gotta go around it.
then all he's got, the only option is to go down through into the floor joist cavity and up and around. And they'll do it because it's their job to get the house wired. But let's try to make our framing and our construction work for everybody on this project, not just like, oh, we're doing this T&M, we're gonna like throw as much material in as we can and make this take as long as we possibly can. Okay, same thing with floor framing. So, let's see, we're gonna go to this here. Okay, so I have this picture in here for you guys. This is one of a deck. I didn't have any from our jobs. I get in like builder mode on the job and I forget to take pictures. I'm not in like educator mode. So I'm gonna try and learn to take some pictures on job sites. But when we get to the end of a floor system, this last joist cavity, this outside joist is sitting on top of our foundation wall, but we need to put blocking in here on the last cavity. Does anybody know why?
Because the wall can't just sit on the plywood.
Okay.
Cave it in.
And why?
Because it doesn't have enough support.
Yeah.
Okay. All right. So we've got our floor joists running like this. So this is one that I see all the time. Okay? So then we're like, oh yeah, I don't think that we can leave it like this, so we'll throw in our blocking here. But, oh, then that one works, because it's right there, that'll carry our wall. This is the framer that isn't thinking about the plumber, the electrician, the HVAC guy, or the insulator. Okay? So you just created this closed cavity. The somewhat conscientious guy will be like, I'm gonna solve that. I'll just stuff some fiberglass in there when we're framing that thing. Then, it takes weeks to frame the house and it gets full of water in there and other messes and that. So, you do not have to have a floor joist on layout if it's going to be a problem. Okay? The layout is here for us to be able to calculate loads, to have a plan. It's there so that our joists hit the spacing we need on our sheathing. But if we look on our plan, which it's your responsibility to look on your plan and be like, oh, we got a toilet right here, and you look at the plan and you're like, all right, it's going to be 13'6" from the outside to the center of the toilet, and you pull that and you're like, ooh, our joist lands at 13'3½". That's a little bit closer than I'd like to be. Okay? So, is there a problem if I put this joist in a few inches off of the layout? Not really.
Unless you're nailing down a sheeting.
Maybe so.
Just cut it.
So we can deal with that. The other thing, like, we can move it. We just have to watch our span here that we don't exceed what our floor sheathing can handle. Okay? So then you want to look at the span rating on your sheathing. But if you're using a 3/4 inch floor sheathing, you can get up to like 20 inches without a problem, and it won't get like spongy like a trampoline in between the joists. Okay? So that's the one thing that you have to look at every single plan. Make sure that you know where that toilet flange is going to go when you're framing that floor. Okay? And I know because I have not done that many, many, many times, and then the plumbers show up, and you're like, oh, I didn't know I had to be a plumber to frame this house. And they go in the bathroom and they're like, they mark their hole and they cut their floor, and the joist is dead center.
And they look at you like,
And they're like, what do you want to do? And then you got to figure out, are you going to move the toilet, or am I going to put another joist in? So generally, at that stage, it is way too late to change a bathroom layout. So they hack the floor joists off, you run a new one, and it's a ton of work. Where if you paid attention to that right away, it takes like 45 seconds to move your layout a little bit, and maybe 20 minutes because you got to cut your sheeting off a little bit different or something. But way less work than having to put a new floor joist in after the house is completely framed. Okay? The other thing, this is probably the most common floor framing massive screw up that I see over and over and over again, and it's completely avoidable, completely unnecessary, and completely stupid to do this. So you get to the, like, this, most floors typically get built on a 16-inch on center layout. Most houses get laid out on a 2-foot increment to the plan. And so a lot of times you'll end up with your last joist on the floor being like 4 or 6 inches away from the end of the building. So what happens with that, we get this in here, we sheet the floor, and I run my 2x6 wall on top of here, and it just, the inside edge of my bottom plate doesn't quite clear the inside of that joist. And so now, if I drew a cross section of it, our wall is like this, and we got our sheathing, and then our floor joist, the space, and then this other floor joist. Okay? So if my electrician, and then here's our sill plate and the foundation wall. Okay? So if my electrician wants to run a wire up into there, his like home run to the panel, how's he going to do that? He's going to come in here with like a 2-inch hole saw and blast a big hole into there, and then drill so he can get his wire down there. Then your insulator shows up and he's like, what do you want me to do with that dead airspace? And you're like, I don't know, well, what can you do? You know? And so then they come up with something, or they don't even notice it, and so then they put their insulation here, and you get this empty cavity there that's more or less connected to the edge of your floor, and then nobody pays attention to it, and this floor is cold, and so then 10 years later, this floor sheeting rots out from condensation on there. So, does this one have to be there on layout? No, it doesn't. Don't ever, ever, ever do this. Okay? You could take this piece if you need to, and you could stick it back here. And then you can run your blocking like this. The benefit of doing your end joist framing like this, one, it gives you support, so when you put your bottom plate for your wall on here, you got support under that wall so that it can't tilt in or make this rim joist here tip out or anything like that. It's not able to distort that floor system because it's supported with blocking that goes all the way down to your sill plate. Two, it gives a wide open space for your electrician to run his stuff into there. It gives a nice open space for your HVAC guy, because he's gonna wanna run, you know, cut his holes in the floor and get his ductwork up in there. And so another option for this is to not even put this one in here, to double this one, and instead of running a 14-inch block in here, run a 30-inch block. Because then it's really easy. Then, all the way around, it's like these end joist cavities. You guys know from insulating, it's crazy easy to, you have awesome access to the rim joists here. These ends are a royal pain sometimes, aren't they? So, if we came over 32 inches and doubled this and then put our blocks like that, it'd make access easy for everybody. And so, at the very least, we need to do it with our 14-inch blocks, and over here, even if these are a 20-inch block, we can do that without even having to double this up, okay? But you should never, ever, ever have closer than 12 inches from the outside one, okay? It has to be at least 12 inches away. Otherwise, you've made the entire project a royal pain for every single person that's going to work on that job, okay? All right, so the other thing on framing a floor, if we have like our floor, our stairway opening from that earlier scenario, and our layout comes like this, there is not a problem with saying like, okay, so do I frame this? Do I put this piece here to frame the edge of that opening 3 inches away from that one? Or do I just, here's more likely what we would see. We got one on the plan that's showing a double here over to the beam. So we got a double there, and this one's 3 inches away. Like, just move it over, put your double. You don't need to have this one 3 inches away. Like, nobody really needs that. And you can measure, and you're like, oh, it's 14 feet. It doesn't matter. You know, we're 15'6" to the edge of this opening. So our sheathing's going to come out at 12 feet and 16 feet. So it's not going to land on this one. So there's no reason to put it in. Let's just move this over, and then everybody that has to work in there doesn't walk down in the basement and be like, what am I going to do with that dumb little 3-inch gap up there? Like, so simplifying our framing always makes sense. Okay? Any questions on that at all?
Why would you need to insulate down there? I don't know, I don't really get it.
Like this here.
Right.
Well,
is that for the basement, or is that
this is minus 20 degree outside, and this is 70 degree inside.
Okay, so it's a basement.
Well, basement, or if it's a crawl space, it's still going to be warm.
You're getting thermal bridging through that piece of wood right there to that open cavity. So you're going to get condensation build up on the floor sheeting. And then your floor sheeting rots out, your wood rots out.
And then your hole.
Now you've got all sorts of issues.
So look at that. Find 70 degrees and 35% RH. And then tell me what the dew point is.
Oh boy. 70 degrees and 35?
Yep.
35 degrees outside.
No, 35% RH. That's not 35 degrees outside.
Would that be over here?
Well, I don't have one in front of me, but I can come look. Okay, so we follow our 70 degree line until we intersect the 35% curve. So, yep, so it'd be halfway between 30 and 40, so there, and then you follow that across.
It would be about
About a 40 degree?
Yeah.
40 degree dew point. So this point here only has to get to 40 degrees before we have water on it. Is it going to be 40 degrees if this is uninsulated? Very, very likely. So maybe not this year, but on our normal winter, that's going to be wet all winter. And wood only has to hit like 19% or 20% moisture content for mold and stuff to grow on it and fungus to grow in that. So
So do you
that's
always
why.
need to insulate the crawl space?
Yes.
Either can you just insulate the floor, or do you need to insulate the sides too?
You can just insulate the floor. I would not recommend that in our climate zone unless the house is built on piers and the space is completely wide open, like no skirt, nothing, and the wind can just freely blow under it.
Really?
But it's a lot cheaper to insulate the skirt, right? It's less foam.
Yeah, but it's more work to build a foundation wall than piers.
Oh.
So that's why, like, if you're going to build on piers, insulate the floor. If you're going to build on a crawl space, insulate the wall. So.
Oh no, that's his truck, yeah.
That's Austin's truck.
Yeah.
Oh, buckets.
Thing's got some trouble. I should say I thought it was an air compressor.
Air compressor.
Okay, so to go back to our points here, like these are the reasons why I want to give you guys this big picture, because you need to be able to step back from like, we're framing, here's the layout, I have to put a piece there. Like, guys get tunnel vision and they're like, well, it's got a line and an X there, it's got to have a piece there, right? Like, they're like, I can get a robot to do that, guys. If that's all you are, you're not worth much. You get paid because you have a brain that can think outside of the box and that can solve problems that a computer can't. So, like, I'm listening to this book right now that's really, really fascinating. And the guy talks about two types of environments. This is the one is a kind learning environment where you do the exact same thing. The rules that applied yesterday apply today.
Sounds like school.
And he says computers do exceptionally well in that environment because you can program them and they can say, oh, when this condition occurs, I do this. That's what a robot framer does. When a line is there, we put a stud and we drive two nails into it.
What's the emotional
Range.
range?
The other kind of learning environment, he says, is a wicked environment where the rules yesterday don't necessarily apply today. And the solution we used yesterday won't work on this problem today. And he says computers are horrifically bad in that environment, but people can excel in it. Because people can pull together bits of information from completely unrelated realms and be like, oh, you know what? That solution that I used to fix that tractor over at Darren Zifko's farm, like, we can tweak it and change it, but it's the same principle to solve this problem on this house. Or that ridiculous class that I had to do in high school when I had to learn this, how to solve this problem. Actually, I can change that a little bit, but the same kind of principle applies here. That's why I want to give you guys a big picture and give you guys a bunch of tools, because I want you to be able to show up on a job and be like, wait a minute, if I slam the floor joist into this rim board right there, when my electrician shows up, he's going to have a pain in the butt time to get his wires run. When my insulator shows up, he's gonna be like, what kind of an idiot would frame a dead cavity that I can't get to? And so I can use this solution to solve this problem. And when you run into this stairway opening, you're like, whoa, we got a floor joist 3 inches away on layout from this. What if we pull our layout from the other end? How does that come out to our stairway? Because I can't move the stairway, but I could change my layout, pull it from the other end. Oh, look at that, it comes right on layout when I come from the other end. Okay, let's just start our board over there, and we'll run it this way. Like, those are the things why God gave you a mind that can think, that you can pull alternate solutions in. And so, don't get tunnel vision, okay? We put blinders on horses because we want them to go straight ahead. But we don't put blinders on people because they have to think, okay? Okay, so this last line there, cutting corners. So I absolutely love doing anything that can save some work, all right? So I am not opposed, like I am the biggest fan in the world about doing something to save effort, okay? That's why I have a semi-trailer out back with insulation in it, because I hate unnecessarily handling product. The same on your job site. I don't want to see anybody touch a piece of lumber until like it needs to go into the house. And so if we can have a machine to do something like to unload a whole banded unit and set it up on the floor where we're going to use it or something, like I love to see that kind of thing. And so I'm not opposed to like cutting corners or like cutting out steps or things that are unnecessary or don't add value to the finished product. What we have to be careful about is implementing some time or labor saving thing that we got to pay back double with more work later. Okay? So a lot of guys will come on our job site and they'll be like, why don't you guys have backing in everywhere for drywall? Well, I hate backing because it adds a massive amount of labor, a massive amount of material, and gives a worse product. It takes significantly less time to put clips on your drywall than to put backing wood in everywhere. The drywall
for like a corner.
What's that?
Like for like in a corner, right? It's like that.
Yeah,
Like there's one
corners,
missing.
top plates, like the typical, the way the industry ran when I was your age starting out, every single top plate had a 2x4 or 2x6 on it that stuck out 1.5 inches or 2 inches, so you had something to screw your drywall into. Every top plate in the whole house. So you'd take a 2x4 interior wall and you'd slam 2 2x4s down on top of it, one to stick out each side. Every gable end, every corner, like we put heaps of backing wood in, right? And it adds all kinds of time and it gives you a worse product. So
Yeah, that's what Fred wanted to do yesterday. He's like, your dad likes clips, but I don't know, I'm just gonna throw this back and put it in.
yeah, so it's like, why would we use more lumber and put time into something that gives a worse product? It doesn't make any sense at all. Yeah, we got to change the way we do things a little bit, but so that there, like, that's the kind of shortcut that drives me absolutely crazy. Like, oh, we're just going to throw a piece of backing wood on here. Why? Does it give you a better product? No. So the ladder blocking that I like to see to hold where a wall intersects another one, it holds, it makes your corner straighter than running backing wood. Because studs can be crooked, right? You guys have all seen a stud that's as crooked as a snake. So you frame a wall, like, you know, here's our one wall, and then we have our other wall intersecting, and we got this 1.5-inch stud here. From the top down, like, you have a 2x4, a lot of guys will then stick a 2x6 on the back of it. Nail them together. Okay? But if this thing is like crooked, then when I put my drywall on, I gotta push that sucker over to straighten it out. When I put my drywall on this wall, right? Or it's gonna be crooked. My corner will be crooked. But when I put ladder blocking in here, if this stud is decently straight and then I nail this one to that, is my corner going to be straight? Yeah. It'll be beautiful. So that's why I want to see it done this way. The other thing is, if this is an outside wall or an inside wall, it doesn't really matter, but particularly if it's an outside wall, I get full cavity insulation. I don't have another piece of framing going all the way through the wall. It's really easy for my electrician to come and he can drill through one stud here to make that corner. So it's super easy for him to run his stuff. Like, I can't think of any drawbacks for it. So, except that I gotta put a clip on the drywall, which takes all of about 35 seconds to put 4 clips on the end of a sheet of drywall.
What is that?
So,
What do the clips look like?
Let's take a break. I'll go grab some drywall clips for you guys.
Just normal.
Where's my pen? Who's
That floor truss is too close to the block, so you could barely get down and spray it anyway. So that was lame, but
Yeah.
I saw that constantly. Doing basements and crawl
It's all the
spaces.
time. And it's like, this is not hard, right? Like, it adds like no work to the job of framing. Literally, I mean, like, you've put these blocks in, Justin, like, it's not hard, right?
No, it's a pain in the butt though. But you still gotta do it anyway.
If Justin can do it, anyone can
It's
do it.
it's a little bit of work at the time, but what it saves in the long run is so massive that, and so like, that's why I want you guys to understand some of the stuff so that you're not like, I don't know why I gotta do these stupid blocks in here. Like, this will pay you back so many times over.
Well, I know I gotta do it.
So
It's just like you're balanced down there and your knees kind of hurt and it's pulled out. You're trying to nail it.
that's just normal.
Yeah, right.
What's the proper way?
There's fun framing.
So if you have a double plate,
To do what?
toenail those on the, if you have the double plate, is it better to toenail it from the sides or from top
And
to
then you
bottom?
fall on the thing and
So
Or
what
just
if you
fall off
put
altogether.
this piece in,
You're good at that.
nail them all
Oh,
through the end, and
Yeah.
then put your second one in.
I've
Yeah.
fallen off.
Yeah.
Sometimes.
True.
So that's the ability God gave you to use your head and think like, oh,
Well,
maybe if I leave this one out until I get the other one in, it'll save me some work.
Gabe never got that.
So,
Can you explain, like, with the clips in the drywall, but then the other bad solution? I've never dealt with
Okay.
this.
you guys
So I
can look
don't
at
know what you're talking about.
these are drywall clips. Okay. All right. So, oops. Guess we have a ceiling up there. If I have, let's say this is the end stud, and here's my outside wall. Typical, guys would put some kind of backing in here so that when I have to run this sheet of drywall, I have backing I can screw it into. Yep. Okay? Like that.
Red lights.
And then I put the sheet in this way, screw it into this piece, or put this one on first, and then this one, okay? And that works, and it's been done for many, many years, okay? What I want to see is this end stud then our other wall is here. We'll put ladder blocking, like 3 blocks in here, so every 2 feet you have a block. So it holds the stud straight. Then hold the end of that drywall, and then your wall sheathing bumps into that. We would say, let's just leave this off. When we run our ceiling drywall in, then it just gets a screw or a nail through that clip at the end wall to hold it in place.
Yeah, definitely less bulky.
It's so fast. Like, the time it takes to throw 4 of these on, like,
We should have did that at our tube
you have them in your tool belt, you get your drywall cut, and you're like, there we go. Took 15 seconds. Then you put it up, joop, 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 screw. It's no more time than it takes to screw through the sheet. So it literally has like almost no time to hanging drywall, and you eliminated the 25 hours of having a guy run around and nail backer wood everywhere, and you eliminated all the cost of backer wood, and you get a better product, because particularly where I really don't like backer wood is on a top plate on a gable end wall, because most guys, you'll have, so if this is our top plate, if we had another piece of lumber, your gable end truss sits on your top plate like this, and it's never tight. There's always a gap between it, like that, or something. Then they'll take and they'll butt a 2x4 tight into that gable end truss and nail it down, and now you've got this gap that goes between your backer wood, between your gable truss right to the outside, and the wind just blasts through those things. You guys know how stuff leaks, like a little tiny thing, yeah, you got that wood nailed tight together, it still leaks like crazy. And then most of the time, the way most guys run their sheathing, the sheathing has a joint right there too, and so sometimes you can see daylight shining through that gap. So that way, when we go and we put a clip on, then from the attic, the joint looks like this. Now I can go up here and I can insulate, and I get that thing sealed so well.
That'd be nice.
So,
how far apart are you put those clips? Like, if you wanted to.
well, I put 4 of them on a 4-foot wide end of a sheet.
Okay.
You can paint right over these.
No, they get
They can come all the way.
Oh, with the other
Thicker.
sheet.
It's
Oh,
thicker
I
than
see.
that.
Yeah.
Nice.
Yeah, none of the clip is visible when they're done. So,
We should put that on.
okay. Okay, any other questions related to that?
I have been some water, so.
Good answer.
Okay. Okay, all right, so your layout can be modified. So if you're gonna modify your layout, there's not really any compelling reason to modify your layout unless you are modifying it to help carry a structural load, okay? So, or if you're modifying for plumbing, like a toilet flange or a bathtub drain, like that's the other one to look for. Tub drains are not as difficult because it's just a 2-inch pipe, and so it's a lot easier to adjust around the floor joists.
How big is the toilet pipe?
4 inches. So, okay.
That's so funny.
Okay.
Okay.
Okay. All right. So here's a here's kind of a flow chart to the typical framing process. You frame everything according to plan, and everything went just beautifully smooth. Then the other trades show up, and your plumber comes in and he cuts the floor joists off because he's like, oh, that stupid framer. He still didn't learn how to read a plan, and so I'm going to teach him. I'm going to cut his floor joists off, and maybe he'll learn this time. And then you have to come in and do a structural repair, and you're like, oh, that stupid plumber, I don't know why he keeps cutting my floor joists off. And everybody points fingers at everybody. So the best way is for the general contractor to take the responsibility that he owns and be like, yeah, I don't like that the plumber cut the floor joists off, but I should have made sure that the floor layout worked for his toilet. Okay? And so it literally takes 0 time to adjust your layout. You know, maybe it takes 5 minutes to like look at the plan and then your layout and pull a measurement, but like way less time than putting a new floor joist in later. So okay. What time is it? So, anytime that you're starting on a project, you really need to get a drawing on it and spend a little bit of time getting familiar with it so that you're like aware of what's going in. You should look at there should be a window schedule typically on a drawing that'll tell you like window sizes, header sizes, window heights. Generally, in most cases, they'll give you a top of window height. As a general rule, if the plan does not give you a top of window height, I'll usually go put my top of the door opening and top of the window openings the exact same. So just a good rule of thumb. Then when you're getting into a plan, that's when you would check in with any of your subcontractors to see anything that they need. The biggest ones are going to be the HVAC and plumbing. The other part where you'd have to check with electricians would be if you've got a structure that's got a high amount of electrical loads, like if they're using electricity for heat, you're going to want to check with the electricians and possibly the power company to see like how big of a service you're going to need, and anyway, some of that stuff. But okay, and so, and then also before you've started any construction, if you're looking at the plans, that's the perfect opportunity to like see things on there where you can help either for no cost give the people a better product, or see if there's any conflicts or issues that you see with the plan and when you may have to like push for a change, or decide that if the customer wants to go with this, that you're not willing to do it and you walk away. So, and in order to be able to evaluate a plan, you need to know what the customer's priorities are, because everybody has different priorities. So some people it's going to be cost, other people like other people would want, maybe they want their like $100,000 fireplace in the building and they don't really care that it's going to cost $100,000. And so
rich people. What kind of fireplace is this?
What's that?
What kind of fireplace costs $100,000?
Big one.
There's like natural fireplaces. You get a stonemason in for 3 months to build a fireplace. Wow. Ooh, that's some money. So So, and then it's also helpful to know, like, if people plan on having big groups in their house, you know, how they want to use it, if it's going to be something that they're going to live in all the time and they want to retire and they want to live there, you know, like grow old in the house, or if they're going to be there for 5 years and they want to sell it in 5 years. So that'll change some things. You know, if they're like 60 years old and they're like, yeah, we want to retire in this house, and they're give you a split level plan, that's the time to ask some serious questions. And then the other opportunity where you can increase the value for no cost would be like if you have a 60-year-old customer and they give you a plan and it shows 5 steps up from the house to the garage, you're like, would it be any interest to you to have the garage at the same level as the house with no steps in between? And they might be like, you can do that? So, because in most cases, customers only are aware of what they've experienced, and if they've never been in a house that has a garage and a house at the same level, they may not even know you can do that. So, that's when you're like, yeah? And they'd be like, wow, that would be so awesome. You're like, okay, yeah, it won't really even cost anything. Just change the plan. So, and so that's where feeling out the customer's priorities and knowing their like time frame for living in the house, you can really optimize value for them. Okay, layout. Most common. Okay, so this is understanding how to lay out for floor joists, studs, trusses, rafters, all of that is a skill that takes most guys like 3 to 4 years to figure out working on the job, unless somebody takes them. It's a bunch of like tutorial time to really teach them what's going on. So I'm hoping that within the next 20 minutes I can teach this to you guys well enough that you'll be able to implement it on the job, and the next time you're on a job you can be like, oh, I can lay that wall out, and people will be like, really? Okay. And then they'll be watching like, is he gonna screw it up? So I will. Okay, so most common layouts, 16, 19.2, and 24. So if you look at the tape measure, we have marks at 12 inches, 16 inches, 24, and 19.2. Wait, okay? See that? 12, 16, 24, and 19.2. So there's every good carpenter's tape measure will have these little diamonds at the 19.2, and if you follow them, you find out it comes out perfectly at 8 feet. So you can run a 19.2 layout, and all of your sheathing will come out. You know, you don't hit on 48, so you have an irregular half sheet if you're running like, you know, staggering your joints. But, okay, so the most challenging mathematical hurdle to overcome in construction is figuring out how to run your layout without screwing it up from like one plate to the next, or one rim joist to the next, or so on, so that all of your layout comes out at your 8-foot spacing for your sheathing. So,
I'm hoping that I can simplify this in a way that makes sense. So if I am blowing past you and or not making sense, stop and ask questions, okay? Or stop me to ask a question. So what we're looking for is we want to lay out, this is a 6 foot long piece of wood here. We want to lay out so that when I put this at the edge of my roof, that when I get to the other end of this, it hits the center of my rafter or my truss, okay? So, I'm going to do a 2 foot on center layout, and what everybody new does is they'll put a mark at 24, 48, 72, 96, and then, you know, we got to put an X on it, because I saw somebody do that. So they square their lines, they put their X, and we nail it all together. And then we go and we put our sheathing on, and we run that flush to the end. And what do you know? Did it hit the middle of our truss? Nope, it's on the side. Dirty dog.
Guess I gotta do some blocking.
Okay? So what went wrong?
Let me go back.
So there's a reason why this is not a 16-inch layout. It's 16 inches on center. Okay? So when we hook on the end of our wall or the end of our roof, we're measuring 16 inches to the center, not the edge. So how do I know where the edge is? Because a line down the center is really hard to put a rafter on or a stud or a joist on, because as soon as we put it on there, we just hit our line, so we don't know if we're at the center or not. So what do we do?
3/4 of an inch. Yeah.
3/4? Why 3/4?
Because it has half a foot.
Okay. Okay. What if I got something different? What if I have a 3.5 inch floor truss?
Then you go.
What is that?
What would it be? 1 3/4.
Okay. All right. This guy can think. So, if I was going to put a 3.5 inch floor truss at 16 inches on center, where would I put my first line?
15 1/4.
14 1/4.
Okay, 14 1/4. So Brady can do math better than Gabe today. Okay, so we'd put our mark at 14 1/4. Well, then where would I put my next one?
The same 16 inches over, but then you go back to.
Okay, so what would it be, Justin?
Let's see, 30 1/4.
Okay, 30 1/4. And that's pretty easy. Now that I've done that math twice, I can say, okay, I'm 46 1/4. I'm 62 1/4. 78 1/4. So on. And so then I can go, where'd that line go? I put my marks on there. And then what do you know? I put my 3.5 inch piece on, and I'm dead center of it. And I run my, well, this won't work with a 6 foot. So, but if I had a 4 foot piece, it'd come and presto, I'd be right in the center of that framing member. So, what if I have to frame a roof with a LVL that's 1 3/4 wide? Then how would I do my layout for that?
5/8.
Okay, it's 5/8, right? 5/8 times 2 is what?
10/16.
Okay, 1 1/4 inches. So it's got to be bigger than 5/8. It's
Wait.
bigger than that.
How big is the?
It's an inch and 3/4.
So half.
So it's 7
is something.
7/8, because an inch and 3/4 is 14/8, right? So half of that is 7. So then I would go, and I'd go at 15 1/8. And it would make my layout start at.
So the
Man,
extra
you
represents
have to-
what side the board goes up.
Yep.
Yeah.
Yep. Okay. All right. Now, we have a really long wall. Let's go back to this floor plan, wherever it was. There we go. Okay. We got a 52-foot long wall. So we're going to frame this thing. We're going to use 16-inch top and bottom, not 16-inch, 16-foot top and bottom plate lumber. So I run my layout, and let's say I'm using a 2-foot on center layout. I get to the end, and so if I have a regular stud, I'm marking this at 191 1/4, and then I'll put another mark at 16 feet, okay? Because that's the center of my stud. And then,
Oh, you're doing your connecting them.
then I take and I mark that, because that's where the edge of my stud goes. And I mark that, because that's where I'm cutting it off, okay? So then, we frame that wall, we tip it up, and I have to lay out this next section. So, where do I start my layout? What measurement do I go at? What's that?
Inch back from that, because then you cut that one.
Okay, how much back did I cut that?
I don't know.
Okay, so I cut it at, I marked it at 191 1/4, and then I cut it off at 192. Because we're framing the wall, so our studs are 1.5 inches wide, right? So it's 3/4 back.
So you just go 16 on the center.
Okay,
So just 16,
okay.
right?
So,
Because it's half.
if I went 16, where would that 16-inch mark be?
Oh. No. No, yeah, that's right.
Okay. So, my sill plate, my stud. So I ended it in the middle of the stud, right? So then my next plate is running this way. And so if I'm hooking my tape on the end of that, where do I start my next layout? What number?
16. If
Okay.
you're doing 16.
Okay, so if I put that mark here at 16, which side do I put the X on? Okay? Then when I run my sheeting,
No, the X would go right in the middle of it, or you'd have to
No.
move your line. Right?
No, because he's already halfway through. You don't have to do anything changing. It's already 16 inches over.
So you,
just
well,
set it
where's
on.
that mark then? If I'm 16
mark is on
inches
it.
from the middle of this to that mark,
You're covering up the mark again.
The
That's what
mark's
you're doing.
center, you gotta
mark
move
is
your line
center.
over.
So you have to move your line over. You have to add a 3/4 inch and mark it on the other side,
Add
or take off 3/4 inch.
okay?
It all depends upon where you want to put the
stuff
X.
that has every new guy out in the field like scratching their head or laying it out wrong, and then you run your stuff and it's like, dirty mutt, my sheathing won't hit that stud. Okay,
just
that's
mark
why
it
I'm
this
making
way.
you guys
Like
wrestle
this,
through
like
this.
this, right?
Where do we put the mark?
3/4 inch back.
What's that?
3/4 inch back.
Okay, why?
So that the
The line isn't covered.
16 inches from the other porch.
Okay, So if I measured 16 inches from the center of this, it'd be to the center of that. Okay? That's great, that's my layout, but that doesn't help me with where do I place this stud at. Okay? So, anytime that we ended our last plate in the middle of this stud, we have to account for this thickness that we get our line at the edge, so we would go and we would start our next layout at 15 1/4. So you theoretically, on any job we're using multiple plates, you could lay all of them out and mark them all out by starting at 15 1/4, 31 1/4, 47 1/4, 63 1/4, so on. Okay? And your layout will work out. And then when you get to the end, instead of cutting it off at 191 1/4 or 192 3/4, you're cutting it off at 192. Because then that layout will end dead center of the stud. And then when you do your next one, you just don't put a stud in at the end. You don't put a first stud in. You just tip it up and slide it in under that one.
So I say, you usually want to go, like, depending on which way you're going, you usually want to go have the stud further marked away from your other stud, right?
Okay.
You can go, like, I don't really care if you go at 15 1/4 or 16 3/4 or 23 1/4 or 24 3/4, it doesn't really matter to me. It generally works better to go back because of one reason. Do you know what that might be?
So that you're...
16. No,
I don't know.
Okay. It's so that if I'm marking 3/4 short of my center line, when I get to the end, I can put a mark for my last stud, right?
Yeah.
If I'm going 3/4 past, there's no wood for me to mark it at 96 3/4. That's the only reason why we would typically go to the short side versus the long side. So, okay? So the harder one is if we're going to lay this out at 19.2.
Diamond.
Right. But then I'm like, going to go 3/4 back from that.
Ooh.
Well, it doesn't exactly, it's almost 19 3/16.
but it's rough framing.
So take 3/4 off of 19 3/16.
You just go back to a half.
Yeah, what is it?
18 and
half there.
7/16.
Yeah. So it's just like a little bit more challenging math to do. Like you're not going to be able to go like, okay, 7/16, but then you get out here and you're at 38 and halfway between 3/8 and 7/16. And so then it's like, So generally, like most of the time, if you're using the 19.2 layout, like for me, just because I'm not that fast at my math on the fly, like I'll go and we'll go at our 7/16. I'll drive a nail in there and I'll hook, and then I can go right on my diamond mark.
When do you ever use that though?
On
So, what?
That's
foot
very fast.
You know, everything else works for 8 foot too.
Yeah, it saves you having to think.
Wow.
So, because after that first mark, then we can go right at our mark.
Right.
And if you have a hard time with the 3/4 inch math, you could do the same with that. You could drive a nail and hook on that, and then just mark on your big red mark or on your 2 foot mark. So, okay. So one other tip, guys, when you are measuring in construction, do not use feet and inches and fractions, okay? Do not ever give me a measurement and say, yep, it's 9 feet, 6 and 15/16. Okay, I don't ever want to hear that from anybody. I want to know inches and fractions. So 1/15 and 15/16. Okay, the reason why is there a difference between 3 feet and 3'6" in length? Yeah. There's a big difference. What if somebody says 3'6" and the other guy goes
36 inches? No.
36, cuts it off, throws you the piece. This is too short. I thought I told you 3'6".
Oh, I thought you said.
Oh yeah. I heard 36.
Well, see, and then you write it down and you can confuse yourself.
So you will eliminate a massive amount of miscut wood by measuring in inches and fractions. And that's why our tape measures have a continual measurement in inches, okay? Like we can go all the way out and we can say it is 292 inches long. Okay? That is very hard to screw up.
So it's just kind of a universal measurement for...
It's because we're all humans and we're all fallible, and it causes you risk mishearing and miscommunicating by going in feet and inches. Does it work? Yeah, it works. It's just more prone to error.
Most people have to be on the same page.
Exactly.
Versus everyone just kind of goes by.
Well,
or most people.
Yeah, so in like, I guess at the risk of embarrassing Justin here,
Yeah.
we had a beam at the house the other day, like a $400 beam that I ordered 12 feet long, and he went out and measured, and however he read his tape,
I said 12 foot and 1 inch.
12 foot and 1 inch, and
Cut it at 112
he cut it at
inches.
112. So 112 is the measure in inches, because it reduces your error a lot. So if he had been like, it's 145 inches, you would have never cut it off at 112. So, okay?
When you're measuring up the for your stud spacing, and you get down to the end and you have two studs that are really close together, say like 4 inches or less.
Yep.
Can you just eliminate the one, or do you have
You
to
could.
have it?
So the challenge, so it's something that you just have to weigh. Structurally, if you're running at a 16 on center layout and you got one 4 inches away, you don't need it. Like structurally, when we get in, when we have the class on the building codes, if you have a 1-story house where this wall is carrying the load of one roof, a 2x4 stud is fine at 24-inch spacing. Okay? If we go to, we're carrying the load of one floor and one roof, a 2x6 stud works at a 24-inch spacing. So
26? 24. Did you say 26?
I don't know, I meant 24 if I did. So, yeah, so 2x6, 24 on center, works to carry a 2-story house. You could go a 2x6, 24 inches on center on floor 1, a 2x4, 24 inches on center on floor 2 if you want. Generally, we go with a 2x6 to give a greater insulation thickness, but structurally it's not needed. So like 99% of the buildings that we build, you don't need anything more than a 2x6 spaced at 24-inch centers. structurally. So there are other reasons, like one of the most frustrating things on the planet is when you expect a piece of lumber to be there and you're nailing trim, or you really need something to hold a piece of trim, or you have something with your siding and it's like, I drove 26 nails through here and I still can't find that stud. So, you know, so that's where it's like, do you really need it? No, you don't. And a lot of times, like, I've done enough trim work and it's like the piece of trim is twisted and you're like, I would really love to have this nail here, and somebody left that piece out because it was 3 inches away from the other, but you don't know that there's a piece there 3 inches away because it's covered by sheathing or drywall. And so now with the really nice stud finders, you could go and be like, oh, we got one right here. So it's, anyway, but my dad, when I was a kid, well, we had a relative, still have a relative, but he was all he did was framing. He had him and 4 guys, and all they did was frame. And if they had a stud come, like for like a window, like a jack stud or something, and or if like, where's our drawing on the window? So if they have like the king stud and shoulder stud and the layout has a stud less than 3 inches away, they just leave it out. So, and really when you have something that close and you have a door or a window, like there is no compelling reason to be like, yep, layout puts one 2 inches away, we got to put it in there. Like I would say 100% of the time pull it out. Unless like that's exactly where your sheathing layout comes out, then like, well.
What if you only have like underneath your window, you only have 2 studs or jack studs, and one's really close to the king stud? Just push it all the way up and just leave it there.
You could do that.
Yeah.
Like sit it here instead of putting it 3/4 of an inch away.
Yeah.
Yeah, that would be a great, excellent call.
We do that a lot.
So, yeah. So.
Oh man, I'm actually remember that.
Yeah. Yeah, you were there for a long time, Colton.
Okay. Questions? Okay, so on layout, 16 on center is going to be your most common layout. It works with all standard sheathings. It works with all types of siding. It works with all interior finishes. Okay? It's typically a lot more structure than what we need. And its major drawback is that it is not as energy efficient for a wall. What does that mean?
Heat gets through.
So, let's take a look here. Well, so when we talk about insulation, we'll get into this more, but, and when we look at, I think in 2 weeks we've got a like advanced framing or high performance framing class. So we'll get into the energy performance of framing more then. But for today, does anybody know what the R value of wood is?
Like 4.
No, way off.
Like 2? 1.
Okay, it's like 1.1. So per inch of thickness. So what's the R value of this 2x4?
3.5.
Okay.
0.3.
So
3.4.
if I lay out my wall, so let's see, we're gonna flip it over so that we have like less marks here to deal with. Okay, so I can lay out here, got my 16 on center. Okay. 8-foot wall. I have 1, 2, 3, 4, 5, 6, 7 studs. Okay? Got a 16 on center layout. When I go at 24, 1, 2, 3, 4. Is that right? 5. 1,
Oh, I see
2,
what you're talking about.
3, 4, 5. Okay? So at a 16 on center, I got 7. At 24, I got 5. So that's somewhere around 25% reduction in wood. It typically comes out to between a like 20 and 30% reduction on framing lumber by going to a 24-inch on center spacing. And what that does, if my cavity is at, let's say, R21, and my stud is at R3.5, and I can reduce the surface area that's at R3.5 by 25%. We just made a substantially greater amount of our wall area at the higher R value. So, and if I take all of the framing in the house in a typical home and we slit it all together into one mass, it's generally right around a quarter of the wall area. So if I've got 1,000 square feet of wall, then I'd have 750 at R21. Wow. And 250 at R3.5. So if I can reduce this number here by 25%, what does that take off? It takes it down to like 175, right? And it pushes this up to 825. 825. So all of a sudden that house that's framed at 24 inches on center gets a nice boost in performance.
And that house is that work class.
Mm-hmm.
They were talking about that and the thermal bridging through the wood.
Mm-hmm.
You know, even though your cavity is R21 and the board is 3.5, it's basically taking the 3.5 away from the 21, so you have a total of 17 and a half.
Yeah.
You said with
Yeah.
less wood material, you have an overall higher R value.
Mm-hmm. Mm-hmm.
Yeah, it was kind of interesting because we got one of our frosts was really heavy frost lately, and Zip was barn and I worked there, and it's like a barn, but it's built really strong because they have all that hay on the second level.
Oh, right.
But it was interesting when we got there in the morning, you could see where all the wood was. The frost was melted on the steel, and everywhere else where it was spray foam insulated, there was still frost there.
Yep.
Wow.
Yep.
It's kind of interesting.
Yeah, you'll see it all the time. It's like it's not so dramatic when you have a truss that's insulated, but when you have a rafter like that goes all the way through the insulation, it's dramatic. So.
We're running any way to reduce that or anything?
We'll get into that in another class. Okay, so the main key with your layout stuff is to remember that you're laying out on center, but your mark doesn't go on the center, okay? If there's only one key that you can take away from today, that's it. That will be the knowledge that you need to be able to lay out a wall, a floor, a roof, any of that. You cannot forget that it's on center, but your mark is not in the center. Okay? Remember that, and you'll have everything you need to know. So, and then typically what I'll do when I'm laying out a wall or something is I will look at my plan, and some plans will give you a dimension like from the outside of the building to the center of the window. Others will give you a dimension to the edge of the window. Either way works. But before I do my layout, I'll take my plate and I'll be like, okay, I've got to be, the plan will give you a dimension in feet and inches. So we'll be like, we got to be 3'6.5" to the edge of the window. So we'll put a mark there. And then you look at your window plan and it says the rough opening is 32 7/8. So then you go and you mark 32 7/8. And then you take your square, and these have really nice lines on it. So you mark at 1.5 inches and 3. You put an X for your king stud, and I'll put an S for my shoulder stud. Then we'll come over to the other side, mark for that opening, and again, X for a king stud, S for the shoulder. I'll do that generally before I run my layout marks, because then when I'm running my layout, I can be like, if we're running at 16 on center, I'll be like, oh, we're way away, so I'll put that mark on there. And on this side, I'm 1.5 inches away, so I'm not even going to mark this one on here. I'll just leave that mark off. Otherwise, for me, generally I have less experienced guys, and if I lay it out and put a mark on there, they're going to put a stud on it.
Without the S, so they see the S and the.
Well, like if I put a mark on here, and you're coming through framing, you're going to throw a board in there and nail it in, right?
Oh, yeah.
Okay?
Yes,
So
sir.
that's where the guy doing the layout has some responsibility. Like, if you're like, I really don't need that stud right there, then just don't put the mark on it. So that's why I'll lay out my window openings. And sometimes, what I'll do too, like you have the option, you lay it out exactly like the plan shows, and you're like, boy, my layout comes right there. That's 7/8 of an inch. I'm just going to scratch these out, and then I'm going to go like this, and I'll put my shoulder there, king stud there, and then I'll measure my 32 7/8, and we'll scratch those out, and I'll remark them here.
Sometimes those scratch out marks get pretty big.
Okay? So, did that make any significant difference?
It moved the window.
It moved the window 7/8 of an inch.
Other than that, no.
So, but other than that, no. So, and for some customers, that would be a huge, like, life-altering deal. But for most people, they aren't even going to notice it. So, and that's where you as you get more experience, you will learn better, like any of those windows there, like if it's centered over the kitchen sink, you probably want to keep it centered, even if you have a stud on layout 7/8 of an inch away, just because they may have cabinets already ordered, and the cabinets are done off the plan layout and that kind of thing. But if it's in a bedroom, I'll move it over. So
let's say that you have the window that specifically has to be where it needs to be, you can't move it over. And then that one stud, that's 7/8 of an inch away, that's where your drywall seam is.
yeah, you don't know that.
You don't?
No, I won't worry about that. So you're pulling from the outside, and if that mark comes at 4 feet or 8 feet,
Yeah.
then I'd put it in. If it's not on 4 feet or 8 feet, I'd leave it out.
And then king stud runs from the bottom
Bottom to the top,
all the way to the top, and the shoulder just runs to the window.
to the bottom of the header.
Did you say something about a jack stud?
Mhm.
What's the jack stud?
That short
The
guy.
little one.
Short guys. So they also, these, with the markers, so it's easier to see. So here's your top plate, and then you'll have, like, most of the time, the header's not gonna be all the way to the top of the wall. And so then they call these little guys cripples. And so like, you will run into, a lot of terms in the trades kind of get like mixed matched and thrown around a bunch.
Yeah, they're called shoulders cripples.
Yeah, a lot of guys call these cripples, and those are cripples, and like somebody might call these cripples. Like it's just that's not necessarily the technically right term for them, but it works. You know, if you're paying attention, like you can decipher the meaning. So. Yeah. So, and hopefully you can learn to read your tape measure so that you're not like, it's 46 and
In
5 lines? Five lines?
Yeah.
5 lines.
Or it's
43
inches
and 4/16.
2 eighths.
5 lines.
So,
2 eighths. Neil did that yesterday.
Fred,
okay, well that is the end of the class. We're a little bit over. So, I guess, any questions at all before I let you guys go? Okay?
Okay.
All right.
On this at all?
What's up?
Are we going to touch on this at all next time, or is it going to be a different topic?
So probably going to hit on everything several times from different angles throughout. So here's my outline. So we are here at January 5th. So next week, we're looking at erecting and bracing trusses. Then the 19th, sheathing systems and high-performance enclosures. 26th, mechanical, electrical, and plumbing. February 2nd, control layers. The 9th, I'm going to be out of town, so there won't be any class. The 16th, we're looking at building codes. So you'll need like something to be able to, you could share.
March 1st.
A couple of guys could share a device. And then we'll look at team leadership, safety, and like, then these are the others. I'm thinking about switching out this roofing for economics. Just because I think that having an understanding of how like economics influences construction is maybe more beneficial than roofing right now. So that's kind of the plan through the next year. So, okay.
My camera was